In the previous lecture, we had introduced the concept of decision analysis. We had seen the elements which are common to every decision problem. The common elements were the decision strategies, the states of nature, and the payoffs. And we had seen that how we list them in a table which is known as the payoff table or payoff matrix. And then we had seen how we can solve the decision problems. We had seen two criteria. One is the optimism criteria, and second was the pessimism criteria. Now let's consolidate our discussion and discuss the third criteria, which is known as Hurwick's criteria. In some books, it will be spelled by TZ, and in some books, it will be spelled as CZ. So this criteria here, you can see that it is also known as the criteria of realism. So what did Hurwitz do? Hurwitz introduced the idea of a coefficient of optimism denoted by alpha to measure the decision maker's degree of optimism. See, if you look at the previous criteria which we had seen, one criteria was a completely pessimistic criteria. Okay, that was known as the pessimism criteria. Then in that case, alpha would have been 0. Okay, since this alpha measures the degree of optimism. Okay, it measures the degree of optimism when the when we call as this when the decision maker's attitude was completely pessimistic. Obviously his degree of optimism will be 0. Okay, therefore we can say that alpha is 0 for the alpha is 0 for completely pessimistic attitude. And on the contrary, we can see that alpha will be 1, that is the coefficient of optimism is 1, that defines the completely optimistic attitude of the decision maker. So alpha is equal to 0 will correspond to the pessimism criteria, and alpha is equal to 1 corresponds to completely optimistic criteria, those which we had seen in the previous lecture. But here Horwitz introduced this idea of coefficient of optimism. He says that decision maker is not completely optimistic, or it might not be completely pessimistic, but there will be this decision maker will be in between those extreme optimistic attitude and the pessimistic attitude. Okay, therefore the alpha should lie between 0 and 1. Okay, in this criteria it should lie between 0 and 1. If it is completely 0, then it is the then we can directly use the pessimism attitude. Okay, we can use the pessimism criteria, and alpha is equal to 1, then we can use the optimism criteria, which we had seen in the previous classes. Okay, so this alpha is, therefore we need to see what is the alpha. Now this alpha will vary from decision maker to decision maker. Okay, you can write here alpha varies from decision maker to a decision maker. Because different decision makers will have different attitude towards a decision problem. Some might be more optimistic, some might be more pessimistic. Okay, therefore it depends upon the decision maker. Now after seeing this alpha, if alpha is the coefficient of optimism, then there will be another coefficient of pessimism, which will be 1 minus alpha. Okay, it's simple. In simple terms, if alpha is the coefficient of optimism, then the coefficient of pessimism will be 1 minus alpha. So Hurwitz's approach suggests that the decision maker should select a course of action that maximizes, okay, that maximizes this term h, okay, h of Sj. Now Sj means what? Sj means the course of actions or strategies. Therefore, if we have 3 courses of action, or we can say that if we have 3 decision alternatives or strategies, the value of j will vary from 1 to 3. Okay, so we will calculate this h, okay, that is equal to alpha multiplied by the maximum in the column Sj. Okay, maximum payoff in the column Sj plus 1 minus alpha, with that is to be multiplied with the minimum in the column Sj. Now you can see that in some problems the Sj will be represented in columns. Okay, that is the strategies will be shown in columns. In some problems it will be shown as rows. Okay, it's not necessary that Okay, sometimes S is mentioned here, N is mentioned here, and sometimes N is mentioned here and S is mentioned here. Okay, so the column is not exactly okay. If we had to generalize this, we can write row slash column or row slash column, depending, but we have to see that these are the payoffs in the strategies. Okay, in the strategy row or in the strategy column, depending upon the question whether he has taken the strategy in the rows or in the columns. Okay, so we can find this h that is equal to for each strategy. Okay, we have to find this value of h, which is equal to alpha into maximum in the sj plus 1 minus alpha multiplied by minimum in the sj. So what are the steps involved? We have to identify the coefficient of optimism. It is usually given in the question. If not given, then we can take it to be 0.5. So I can write if not given, take 0.5. Okay. For each course of action Sj, select the highest and smallest payoff value and multiply these with alpha and 1 minus alpha respectively to get HSJ. So how is SJ calculated? You can see that we have to see what is the maximum value in a particular course of action and what is the minimum payoff in the course of action, and we have to multiply those by alpha and 1 minus alpha respectively. Okay, maximum is to be multiplied by alpha and minimum is to be multiplied by with 1 minus alpha. So after calculating sj, okay, we will get s this value of h, sorry, we will get the value of h that will be equal to alpha into the largest payoff, or we can say that the maximum payoff, plus 1 minus alpha into lowest payoff. So if we are having three strategies or three courses of action, therefore we will get three values of h. If we are having four courses of action or four strategies, we will get four values of h. Then how is the course of action determined? The course of action sj for which hsj is maximum will yield the optimum decision. So after getting different values of h for each strategy or each decision alternative, the one which is having the maximum value, okay, which is having the maximum value of hsj will be treated as the optimum decision. Okay, and also remember that this formula is only applied for the maximization problem. Okay, so in our current question, the problem is of the maximization, okay, which we are dealing yesterday. The problem is of the maximization. Therefore that is the profits are mentioned in that column. Okay, the payoffs are in terms of the profits. Therefore our goal is to maximize the profit, and therefore we have to follow this strategy which I have discussed here. Okay, so let's apply this concept to our problem which we were seeing yesterday. So see here, we have three courses, a course of actions or strategies. Okay, S1, S2, S3. What we are going to select here is the maximum from each this column of this strategy or action. From each column of strategy or action, we are going to select the maximum value and the minimum value. So see, in the first strategy, the maximum value is 18,000 and the minimum value is minus 100. From the second strategy, we can see that the maximum value is 20,000 and the minimum value is 0. And from the third strategy, the maximum value is 19,000 and the least value is equal to 2,000. Okay, so these are the maximum and minimum values. Okay, so I can write them here again. I'm going to write them again. For strategy 1, the maximum value was equal to 18,000 and minimum value was equal to, it was equal to minus 100. For second strategy or course of action, the maximum value was equal to, it was equal to 20,000 and the minimum value was equal to, or minimum payoff was equal to 0. From the third strategy, The maximum value was equal to 19,000 and the minimum value was equal to minus 2,000. Okay, so let me see once again, just to be sure. Okay, fine, 19,000 and 2,000. So once we have got all these maximum and minimum payoffs for each strategy, we can now calculate the value of H for each strategy. That is, H value for first strategy will be given by assuming here alpha to be 0.7. Okay, let's suppose that in the question it is given that alpha is equal to 0.7. That is, this is the coefficient of optimism. Then the coefficient of pessimism will be 1 minus alpha, that will be equal to 0.3. So now finding the values of H for each of these. So HS1, it will be alpha, that is equal to 0.7 multiplied by largest payoff. Okay, you can see that in the first strategy, the largest payoff is equal to 18,000 plus 1 minus alpha, that is equal to 0.3 multiplied by the lowest payoff, which is equal to minus 100. We can see that it is equal to rupees 12570. Now, if we are calculating HS2, it will be equal to 0.7 for the second strategy. Maximum value is equal to 20,000, and this is the coefficient of pessimism, and the minimum value is equal to 0. Therefore, we will get that it is equal to rupees 14,000. And finally, we are going to calculate HS3, that is 0.7 into the maximum value is equal to 19,000 plus 0.3, the minimum value is equal to 2,000. So this comes out to be rupees 12,700. So finally, what we have to do, the course of action Sj for which the H value is maximum will yield the optimum decision. Okay. So if we are comparing these H values, we can see that this is max, which means that the strategy S2 will be selected as per this criteria. Okay. But one thing you have to note is that the thing which you have to note is that it was for the maximization case where the payoffs were in terms of the profit. Sometimes the payoffs are in terms of the loss or cost. The loss and the cost we have to minimize. Okay. For that, the formula will change. Let me write it. I won't solve it, but I will just write the formula. So for the minimization case, that is when payoff is in terms of cost and loss, cost or loss. Then the formula of HSJ changes. It will be equal to alpha times the minimum payoff, or alpha times the minimum cost plus 1 minus alpha times the maximum cost of that strategy. Okay. Okay. So this gives us the HSJ. Okay. Suppose, and after that, what we have to do, course of action will be decided by minimum value of HSJ. Okay, it will be determined by the minimum value of HSJ. Okay, so this is for the minimization problem. We have to be clear, but at most of the time the payoff is represented in terms of the profit. Therefore, most of the problems that will be of the maximization problems. But still, I have told you about if it is a case of minimization, what is the change that is going to be, what are the changes that are going to be, that will take place in the calculation or determination of the optimum decision. Okay, so let's move to the fourth criteria, that is known as, let's see the fourth criteria. It's actually Laplace criteria. Okay, this is the Laplace criteria. Now next criteria is Laplace criteria. So it is also known as equal probability criteria. I can just modify it. What it states is that the average payoff is calculated for all the course of actions. That is, for all the strategies or course of actions, the average payoff is calculated, which is simply the mean average. And once the average is calculated for each course of action, the action with the highest average payoff is selected. Okay, and it is actually for the maximization problem. Let's change it a little bit. The action with highest average payoff is selected, okay, for maximization. Okay, selected for maximization, and for the minimization, the lowest payoff will be, average payoff will be selected. And in brackets, I will write lowest for minimization. So pretty simple criteria that calculate the average payoff, which is also known as the expected payoff, okay, for all courses, course of actions. Now see here, we have 3 course of actions. So for each course of action, I will calculate the average value. Okay, so for, I can write for S1, okay, expected payoff will be, or average payoff, that will be given by the average of all these. Okay, for the strategy 1, that is 4,000. Okay, it's better to write here. For S1, expected payoff, that will be equal to 4,000 minus 100, or in fact it is 100, plus 6,000 plus 18,000. Divided by 4. Okay, so this is the expected payoff for the first strategy, and that will be equal to rupees 6,975. Similarly, for S2, the expected payoff will be equal to 20,000 plus 5,000 plus 400 plus 0 divided by 4. So this will be equal to rupees 14,000. Or sorry, this will be equal to rupees 6,350. And finally, for S3, the expected payoff will be equal to 19,000. Okay, we have to make the summation of all these payoffs in the S3 column. That is 19,000 plus 15,000 minus 2,000 plus 1,000 divided by 4, and that comes out to be 8250. And since this is the problem of the maximization, therefore we will select the highest payoff. Okay, the highest payoff is for this. Okay, therefore S3 will be selected because it has the highest payoff. Okay, had this problem been of the minimization, okay, for minimization we have to select the lowest payoff. Oh, sorry, we have to select the lowest value of the expected payoff. Okay, the average payoff. What would have been selected is we can see that the minimum value is for S2, therefore the strategy second will be selected. Okay, sometimes it is also given that it is in many books this Laplace criteria is given as per these statements. Okay, assign equal probabilities to each state of nature and find the expected payoff corresponding to each course of action. Okay, so what it states that we have to assign equal probabilities to each state of nature. See here, for S1, how many states of nature we are having? We are having 4 states of nature. We can see that for strategy first or action first, we are having 4 states of nature, N1, N2, N3, and N4. We will give them equal probabilities. Now, since there are 4 states of nature, therefore, probability of each state of nature will be 1 by 4. Okay. Here, P will be equal to P1, P2, P3, and P4. They will be equal to 1 by 4. Okay. So each action will be given the equal probability. So the statement is that assign equal probabilities to each state of nature and find the expected payoff corresponding to each course of action. So it is also one and the same thing. Once we have given equal probabilities to all these states of nature falling under the category of S1, then we can say that the expected payoff is equal to it will be calculated by 1 by 4 will be common for all, and we have to make the addition of these. That is 4,000 minus 100 plus 6,000 plus 18,000. Okay, we are arriving at the same value which we had already seen here. Okay, so this is equal to rupees 6975. Okay, so sometimes the statement might be, in most of the book statements are written like this, but it indirectly means that we are calculating the average payoffs. So this is the 4th criteria. Now let's look at the 5th criteria, 5th and final criteria, that is the minimax regret criteria. So don't confuse it with the minimax criteria. We should not confuse it with the minimax criteria. Okay, it is minimax regret criteria. So one was the minimax criteria which we had seen in the previous lecture, but this is minimax regret criteria. So this criteria is also known as opportunity lost criteria or savage criteria. Okay, these are the other names. So what is the principle behind it? The decision maker regrets after adopting a wrong course of action, resulting in an opportunity lost of payoffs, okay, that she would have liked to minimize. So what are the various steps involved in this criteria? First step is that find out the highest payoff of the state of nature. Okay, we have to be careful that for each state of nature, we have to find the highest payoff, okay, not of the course of action. Okay, so this thing you have to keep in mind that it is find out the highest payoff for the state of nature. So in our current problem, what are we having? The states of nature are 4, okay, N1, N2, N3, and N4. We have to find among them. Okay, for N1, we have to find what is the highest state of nature. Okay, highest payoff corresponding to the N1 state of nature, then highest payoff corresponding to N2 state of nature, and similarly highest payoff this corresponding to N3 and highest payoff corresponding to N4. So once we know the highest payoff corresponding to each state of nature, subtract each payoff of the state of nature from the highest payoff. The difference is known as the regret. I would like to write the table again. So these are the states of nature. This is N1, this is N2, this is N3, and this is N4. So what were these quantities? 4,000 minus 100, 6,000, 18,000. So this was equal to 4,000, and the other were 20,000, 19,000. This was 19,000, and what was in the second row? It was minus 100, 5,000, and 15,000. And what was in the third row? It was 6,400 and minus 2,000. And finally, in the fourth row, it was 18,000, 0, and 1,000. Okay, so these were the and states of nature. Okay, payoffs for each state of nature. Just a slight mistake. It was minus actually here, not with this 400. It was minus with this 2,000. Okay, you can see it again. 400 and minus 2,000. 18. Okay, so what is the next step here? We have written this state of nature. This is the original matrix. What we have to do, subtract each payoff. Okay, we have to find out the highest payoff in for each state of nature. Okay, we have to find the highest payoff for each state of nature, and after that we have to subtract each payoff of the state of nature from that highest payoff. This difference is known as the regret. Okay, so we have to find the highest payoff for each state of nature. Okay, and then subtract each payoff of the state of nature from the highest payoff, and this difference is known as regret. So we can see that again here. This is N1, this is N2, this is N3, and this is N4. So this is S1, S2, S3. And what we are going to calculate is the regret. Okay, this table, we can say that is the regret table. Okay, so for the first state of nature, okay, see the highest payoff. We can see for the first state of nature, the highest payoff is equal to 19,000. Then we have to select each state of nature payoff from that highest value. Okay, so we have to be careful that we are considering this row of the state of nature. We are studying we are selecting the highest payoff among the state of nature, and from that row of the state of nature, we are subtracting. We will subtract each element from that highest value. That means if in the first state of nature payoff row, that is this first row, if 19,000 is the highest, then what we have to do here is 19,000 minus 4,000, that will be equal to 15,000. Okay, in fact, 20,000 is the highest. Okay, you can see that 20,000 is the highest payoff in the first state of nature row. That is, we have to subtract each element, okay, each payoff of this first state of nature from this 20,000. Okay, so we'll get that 20,000 minus 4,000, that will be equal to 16,000. This will be equal to 20,000 minus 20,000, that will be equal to 0. and 20,000 minus 19,000, that will be equal to 1,000. Similarly, we can see that in this second, what we call as the second state of nature row, the highest is 15,000. So 15,000 minus 100, that will be equal to 15,000 plus what we call as this minus 100, that will be equal to, this thing will be equal to 15,600, sorry, 15,100. Okay, this will be equal to 15,100. Here we will have 15,000 minus 5,000, that will be equal to 10,000. 15,000 minus 15,000, that will be equal to 0. And in the third state of nature row, we can see that the highest element or highest payoff is equal to 6,000. Therefore, 6,000 minus 6,000, that will be equal to 0. 6,000 minus 400, that will be equal to 5600. And 6,000 minus 2,000, that will be equal to 8,000. And finally, in the fourth row, we can see that the highest, what we call as the highest payoff is equal to 18,000. Therefore, 18,000 minus 18,000, it will be 0. 18,000 minus 0, that will be equal to 18,000, and 18,000 minus 1,000, that will be equal to 17,000. Okay, so this table is known as the regret table. Now, for each course of action, see here the third statement. The first statement, we can see that the first statement was find out the highest payoff of each state of nature. Okay, for each state of nature, subtract each payoff of that state of nature from the highest payoff. The difference is known as the regret. And third step is that select the maximum regret for each course of action. Now we have to look for the column of the course of action, and for each course of action we have to select the maximum regret, choosing the, okay, so first of all, what we are going to do here is we are going to select the maximum regret. See here in the course of action S1, the maximum regret is equal to 16,000. In the second course of action, the maximum regret is equal to 18,000. Okay, from all these course of action of the second, okay, S2 course of action, the maximum regret is equal to 18,000, and in the third case it is equal to 17,000. So we have found the maximum regret for each course of action, and among those, what we have to do is, among those calculated values of the maximum regret, choose the minimum value, and the course of action corresponding to this minimum value will be selected. So here we can see that the minimum value is equal to, among these maximum regrets, okay, the minimum value is equal to the 16,000, and the corresponding is S1. Okay, the corresponding course of action is S1. Therefore, S1 will be the one which will be selected. That's why it is known as minimax regret. We are calculating the regrets, and among the regrets we are calculating, in fact we are calculating the maximum regrets, and among those maximum regrets we are calculating the minimum value. So minimax means minimum from the maximum, okay, minimum among the maximum. Therefore we have to first calculate this maximum regrets, then we have to select the minimum among those. Okay, that's why it is known as the minimax regret. Had it been maximin regret, then we had to calculate the minimum regrets, and among those we had to see what is the maximum regret. But the criteria, okay, this becomes important. The regret criteria is based on the minimax regret criteria. There is no maximin regret criteria. Okay, it is minimax regret criteria only. I hope this is clear to all the students. So this actually was for what we call as the maximization problem. Had there been optimize this minimization problem, there would have been some different, uh, the formula would have changed. Okay, so for the minimization, what we have to do, for minimization what we have to calculate is cost minus minimum cost. Okay, we have to calculate the cost minus minimum cost, and then calculate the regrets. Okay, the regrets will still follow the what we call as the minimax regrets. Okay, it will follow the minimax regrets. So see how we are going to proceed. If we had to do this question, if had this been the minimization problem, what would have done? So if the states of nature were n1, n2, n3, and n4, the course of actions were 4000 minus 100, 4000 minus 100, 6000 and 18,000. This for S2 it was 20,000, 5,000. 400 and 0, and finally for S3 it was 19,000, 15,000, minus 2,000 and 1,000. So here we had S1, S2 and S3. So how to calculate the regret table if we have to draw the regret table? So again we have to see this is N1, N2, N3 and N4, and these were S1, S2 and S3. So to find the regret table in the case of minimization, okay, we have to select the minimum. So see here, the minimum is 4,000. The regrets will be calculated by this formula, that is cost minus minimum cost. What was in the previous case? It was we had to subtract the highest from we have to subtract each payoff from the highest payoff. Okay, now here what we have to do is to subtract the cost from the minimum, subtract the minimum cost from the cost. Okay, so see here we are having in the first state of nature row, okay, this is the state of nature. In the first row we are having the cost of 4,000, 20,000 and 19,000. The minimum is 4,000, therefore we have to subtract cost by, so the regrets will be 4,000 minus 4,000, that will be equal to 0. 20,000 minus 4,000, that will be equal to 16,000. Okay, cost minus minimum cost, that is the cost here is 20,000 and the minimum cost is 4,000. 19,000 minus 4,000, that will be equal to 15,000. Similarly, for the second state of nature, consider the minimum cost is equal to minus 100. Okay, so cost minus minimum cost. Okay, cost minus minimum cost, that is cost is 100 minus minimum cost is also minus 100. Therefore, it will be equal to 0. Similarly, here cost minus minimum cost. Therefore, 5,000 minus minus 100, that will be equal to 5,100, and finally 15,000 100. So this will be the regret for it. Here in this case we can see that the cost minimum cost is minus 2,000, therefore cost minus minus 2,000, that will be equal to 8,000. Finally we will have the cost minus, that is 400 minus minus 2,000, that will be equal to 2,400, and this will be equal to 0. And finally at the last the minimum cost is rupees, this 0, that will be equal to 18,000 rupees. This will remain as it is. So we can see that what are the maximum regrets. Okay, the maximum regret for each is equal to, here we have the maximum regret of 18,000, here we have the maximum regret of 16,000, and here the regret is equal to maximum regret, it is equal to 15,100. And among them we have to select this minimax criteria will remain intact. Okay, minimax, okay, it will remain intact whether irrespective of whether it is a maximization problem or a minimization problem. Therefore, minimax means out of the maximum we have to select the minimum. And out of these maximums, the minimum is equal to 15,100, and this is corresponding to S3. Therefore, this is S3. Okay. So in the next lecture, I will solve one more problem. Okay, I will take one problem and we will calculate all these criteria. Okay, we'll make that a decision making problem by using all these criteria, so that we again get the review of all these concepts which we have learned over the 2 lectures. Okay, so in the next video, I'm going to take one question again, and we will going to solve that question by all these criteria again.